Hi everyone. So today I would like to welcome Flavio Brasil and Adam Hearn, who are both co-contributors to Kyo, the new cool FX system in Scala. Flavio is also a principal engineer at Newbank, and he has a career focused on performance in the JVM. And Adam is a software engineer at Amazon. So please welcome Flavio and Adam.
Hey guys, I'm very happy to see you. Thank you for coming. So Flavio, Adam, I wanted to ask you, what motivated you to start working on Kios?
Hi, yeah. So thank you for the invite. It's great to be in your podcast. We were trying to schedule it for a while, so I'm happy that we were able to do that now. So Kyo is actually, to me, it's more of a passion project. So I've been working on performance and libraries and functional abstractions for several years now. And I normally have like my day job and I like to do open source as a hobby. Basically to explore like different ways of doing things, innovations, and that was the main motivation for building Kyo and working on it. So it has like this focus on providing functional programming in a way that's simpler, that's more convenient to people, but at the same time with good performance to ensure that you can build like larger systems, high scale systems also with the same solution. So yeah, to me that was like the main motivation to start working on Kyo, more of the passion of like building something different, something innovative.
Yeah, I can understand that. And for you, Adam?
Yeah, I started contributing to Kyo mostly because I was very interested in what it was, and I really didn't understand anything about algebraic effects. I didn't understand. Honestly, I was just digging into effect systems in general, and I realized that there was sort of this opportunity because Kyo was so new that there was a lot to formalize and a lot to put together. My first contribution was very simple, is some changing to the way we did logging, but it was a lot of fun, and Flavio was very supportive. So I just started, trying more things, and eventually, the complexity builds, and you end up contributing bigger and bigger things, and that's a lot of fun. So.
Yeah, I think it's a great thing about open source. I mean, it's not like, I think it's a bit scary before you contribute the first time, but I think most people are so happy to have anyone else coming to your project. I don't know, Flavio, how is it for you? But when you have someone like interested in your pet project, you're always very happy and wants to help. So I would definitely encourage people to give it a shot. It's a great experience.
Yeah, definitely. I think for anyone listening, there's an opportunity to contribute to Kyo. I think it's very fun, and we're always trying to, have a good community building together.
And so Kyo, I mean, it seems to be, I mean, for me, I haven't really used it personally, but when I read the documentation, I read all the docs, but it seems to be doing a lot of things. So could you explain a bit, like, what is Kyo essentially?
So Kyo is an effect system, right? So it's a functional effect system library. And the idea is similar to Zio or Cat's effect, for example, but there are a few major differences from them. So instead of having multiple libraries, multiple repository, we are focusing on having a single monorepo where we can basically enforce the same patterns, the same kind of APIs, consistent experience around across like the different abstractions and different solutions that the library provides. So that's an important difference. Another difference is the use of algebraic effects. So Kyo has it's a new innovation of way to encode monads and algebraic effects that basically allows for better performance and usability. So for example, in other libraries, you normally have this complexity of you have some effect and it's in one monad, and then you have another effect that's in another monad, and then you have to nest them, and then you have to handle them, and you have to lit things to one monad to the other. So there's like all this complexity that is because of the lack of composability of effects across monads. So Kyo basically gives you all the effects in a single monad, and you can basically compose them freely. That becomes like really powerful because it helps us, for example, in the development of the library itself, because if you see, like, for example, a string implementation, I don't know, in Zio, it's a monad, and then there's like all the effects implemented in that specific monad. So, for example, resources and like the proper streaming itself. But in Kyo, you are basically composing different effects within the same monad. So the implementation for string is fully isolated from resource safety, from resources, for example. Or the implementation for environments is fully isolated from error handling, and they don't know about each other, right? So the internal implementation of the library is also more structured, simpler,
More modular.
through more modular through algebraic effects. And most of the effects don't know about each other. Like Aborts is like its own effects. There's nothing, it doesn't know anything about any other effect. And that becomes like really good for us to develop the library because we can have like proper isolation of the implementations and they can compose with each other freely, right? So you can have like really advanced effects like parsing, for example, with backtracking and like all the state management for parsing mixed, I don't know, with asynchronicity, right? So you can do things in parallel, or you can mix error handling with IO, or there's a collection of effects, right? And the promise is basically the main difference in terms of usability is the question of like composing effects. But we have lots of innovation. So for example, we have like a way of encoding the monad. So you don't need to distinguish between map and flat map. What else? We have like more user friendly abstractions. For example, we have a debug effect that shows you the trace of execution with each step, like with snippets of the code. It's really useful to debug things, for example. And that's like leveraging all the things that you get from the fact that you have control over the computation, over the effect, to be able to provide like a better experience to the user, right? There is some challenge because Kyo has like a lot of new things, so people need to get used to it. But it's a quite complete and flexible way of like doing functional programming on the JVM. And we also support native and JS as well.
That's very interesting. I have lots of questions for you, but before that, I would like to take a little step back about, maybe for, I guess most listeners may be familiar with effect system, but it might be useful to define it. So this is something I struggle myself to essentially just say, like, what is an effect system? So how would you define it? How do you explain the reason of an effect system or the benefit of an effect system?
Yeah, I think effect systems provide a framework, a structured way of deferring computations. So one of my favorite words when describing effect systems is suspension, because they allow you to delay the evaluation of your program. And so this gives you a few benefits. You can encode programs as values. Often effect systems include, many features like error handling or asynchronicity, but that's not necessarily true of all of them. You could have a very simple effect system just built on the suspension of IO. And the reason this is important is not just for referential transparency, but also for features like retries. You can basically bake in many of the features that, if you're looking at a JavaScript program, and I've written many of them, you need to build a lot of tools, or you end up using a lot of libraries to, put all this together. An effect system really builds many of these components right into the core of it, and it's based solely on suspension. So by suspending the code and deferring execution until evaluation, you sort of split how your program works. It simplifies a lot of the user-driven development, though it may kind of introduce complexity in terms of how you write your library. So,
yeah, I do think that the beauty of functional programming is a bit like Legos. You build, like, you have your small blocks and you combine them together, and you never risk anything. It's never going to blow up. Like, you can rearrange it as you want. This is like this nice and safe way to build like functional program. And I think FX system allows you to do this. It makes testing easier, composing stuff easier. So I think it's a bit tricky to explain to someone who never used it before. Is the kind of things you may need to try. And it may not be useful for, like, if you're just scripting, it may be overkill. But when you build like a real world application, this is definitely useful.
It's definitely invaluable in real world applications. I think it's very hard to describe. I think the common case on Twitter or on X, people are arguing over why you even need an effect system, and it's like, I can't share you a 2-line snippet that explains it, but I could show you a 30 to 100,000 line app that's so much less. It's not 1,000,000 lines because it uses an effect system, and it provides much stronger guarantees onto ensuring that your resources are finalized, ensuring that you're throttling the correct way, you're backing off when necessary, all those things.
Yeah, and it makes also refactoring, I think, safer, because one thing is, like, your program should be optimized for refactoring, because you're gonna write it once and update it many times. So you need to be able to update it safely without to have this mental model in your head.
That's 100% true. Yeah, fearless refactoring is not just functional programming, but definitely with effect systems.
So maybe what could be useful is if we could have a quick look at Kyo in the real world. Like if I don't know, Flavio, would it be possible to have some kind of small demo to look at how the Kyo types works and how you can combine effects together?
For sure. Let me share my screen. Cool. So Kyo, as I mentioned, it's a new way of encoding computations. It's different from other effect systems. So in that sense, I would encourage anyone learning it or trying to get to know it is to try to take it from a fresh perspective, right? So don't try to think of it in terms of the solutions that we have today, that is different monads and nesting and etc. But focus on what the library actually provides, right? Because the building blocks are very simple. There are 3 main building blocks that we have. That is basically the painting type. Painting type, that is essentially the monadic interface that Kyo provides. And it has an infix type notation that's a bit different. So I'm going to explain how that works. The second thing is effect widening. That is how you can compose computations with different requirements together, and then how to transform computations. So that's the basic building block, right? I would say actually I'm going to put effect tracking here. That is basically the painting type, right? So these are the 3 main things that Kyo has. Internally, the painting type is actually, I'm going to put it here. Actually, let's do here. The painting type is the lesser sign. So it's defined as any fixed type. And it has the type A and S. So what this means is basically a computation that is going to be producing a value of type A. And it has a set of painting effects that need to be handled. So the computation uses some effects and they are tracked in this type level set. And it's a type intersection, so it keeps accumulating the effects that you are using, basically.
So it's it's like a set of effects, right? It's something like a bag of effects, right?
Yes, exactly. And it's unordered, so it's a type intersection. You don't have ordering at that level. It's just a type level set, unordered type level set. So for example, we can have computation that's going to be producing an integer, and it's pending, let's say, I/O, for example. So what this means is here we are using the infix notation. That's the way we use it at Kyo. But we could also do like this. That's the same thing.
I guess it's more readable the other way, the infix way.
Yes, exactly. The idea is to have something that's more readable, more lightweight, right? And the way that we read it is basically because the lesser sign is the monadic interface. It's the Kyo's monads, and we call it the painting type. Okay. And the painting type, we read it this way. It's going to produce an integer. It's an integer pending I/O, right? So in order to obtain the integer, you're going to have to handle I/O first. Make sense?
Yeah.
And you can have multiple effects because in ZO, let's do the equivalent in ZO, for example. Let's say that we have a computation that can abort with a string and requires a value from the environment of type integer.
Oh, sorry. I think we got colliding.
Oh, yeah. Editing the same line doesn't work well on live share. So here we have another computation that is an integer pending a possible abort with a string value and requiring an integer from the environment. Right? So that's a pattern.
So you're comparing this to ZO, where ZO there is 3 types. The A type, which is the value you produce, so this will be the int here. The E type, which is the errors, in this case, would be the string, and the environment, which is dependency injection, here is an int. It's another int.
Exactly. So the equivalent in ZO would be string that is the failure is a second, right? Yes, and a and int, right?
Yeah, maybe
So
let's make it the third one different so that
let's do exception here just to
yeah,
make it easier to understand.
that would be in the middle, right?
Yeah. Or this normally would be a service, right? It's not an integer, but something that you inject into the computation.
You can say a database or something like this.
Yeah, exactly. But Zio is limited to these two effects, abort and environment.
Yeah.
Right? In Kyo, you can have as many effects as you want. For example, you can say that this computation uses memorization. That is another effect. Or you can say that this computation uses async operations. Right? So you keep adding these types to the pending set. And that's something that the library does automatically, right? So as you compose computations, as you use effects, they are getting added to the pending set. Make sense?
Yeah, sounds good.
Cool.
I think one of the funny things about Kyo is you initially think, I'm going to have to write all of these effects. They're going to be everywhere. But it turns out that the beauty is type inference works very well. And so in most instances, you only need to supply the very final return type, and that's all you need to provide.
Or not even that. Like you can omit types and just keep like doing as where possible without declaring, right?
Definitely.
And this is something that's going to be expressing the computation. So you are able to express what the computation is going to be producing, the final value, but also everything that the computation can perform. And you then have to provide handling of those effects, right? So, for example, let's say I'm going to actually write a computation here so we can move this here. So here we can have a computation. Let's say that we just get something from the environments like an integer. So env.get an integer, and then I map it +1. Right.
So here you're saying I'm fetching an int from the environment and I add 1 to it.
Exactly.
Is that correct? Yeah.
Yeah. So the return type, the compiler is going to infer that, but you can also put it manually. It's going to be an integer pending the environments because you are getting something from the environments. And at this point, you don't know what you're getting, right? So at some point you have to provide that. So you can do env.run, and let's say that we want to provide, 42, and the computation that requires that. Okay. And that's going to be...
So here you're injecting 42 as to say, okay, 42 is my environment, essentially, the int in my environment.
Exactly.
Makes sense.
The run methods on effects like environments is the effect handling methods. We also take a different approach from normally when you have like algebraic effect libraries, there's a lot of focus on the user building effects. Our main focus is providing the effects that are the most useful, the most like that work well with each other.
Yeah.
So users can just like leverage that instead of having to build something more low level, because building effects is something more abstract in terms of concepts that you have to understand.
It is possible. The library is developed in a way that any user could build effects. We just realized that most effects everyone wants to use, so we might as well supply them all, so to speak.
I see.
And then what's going to happen, like once we handle using the run method from the environments, we are going to get rid of these requirements that an integer from the environments is required. Makes sense?
Yeah.
And then the way that we represent empty set is through any. So you basically say like, once you have a computation that's pending any, you can actually call eval on it.
Yeah, so essentially like a value pending any is like a pure value. It's a value with no effect.
Exactly. There is an internal effect within the library, within the kernel, that is used for stack safety. So once the library sees that you are in a certain depth, you can introduce suspensions that are internal to the kernel. So at this point, the B can be a pure value, the actual integer, but it can also be a suspended computation with the internal effect for stack safety. And the eval is going to be basically handling this internal effect as well.
Okay, yeah. So it may not be an int in a machine, but semantically speaking, it's like an int, right?
Exactly. Yes. And then if we run, for example, here, we are going to see the results 43, right?
Yeah.
So what's happening? We are injecting the 42 to get rid of the requirements of the environment. This is going to be injected here and then adding +1.
Yeah.
Right.
It's a nice thing for testing. Like, if you have, you can have your prod application depending on some real environment, and then your test application, you can inject, let's say a mock or something like this. I guess this is a typical example of the env effect. Is that correct?
Yes, that's correct. We also have layers similar to Zeal. Adam and Kit worked on it, and it's also you can compose multiple environment values and then build the environments to pass through the environments through the env effect, basically.
It has all the auto wiring features. So if you just put a bag of layers into a function argument, then they'll all be built the way that you expect.
Also, one thing I found interesting with Kyo from the documentation is that you can have multiple times the same effect. I guess it need to have different values. For example, you can have multiple environment effect. You can have an int and a string, for example, right?
Yeah, that's a good point. So let's do a computation like that. So, I'm going to be using a for comprehension now. Or so we can get, for example, let's say int value and get int string value string, and then I don't know, we can just, let's say we use that both. And let's do an exercise. Can you guess what the signature is going to be here, Julian?
So I would say it's something so at first it's the value that you produce is a tuple int string. So it's going to be this, then the pending type. And then we have two effects. We have the env int and the env string. If I remember correctly, when you combine two effects together, you need to use the ampersand. So I would say env int ampersand env string.
Exactly. Actually, you can. I was expecting the compiler to infer this env string.
Okay, yeah, that's what I would have thought. Yeah.
So, but the environment effect is also has variance as well. So you can actually this is equivalent to this.
Okay, and can you use the two definitions, the two versions compile, or? Yeah,
it compiles too. It's equivalent. Okay. For the compiler, is the same thing in terms of types, right?
It's interesting.
The way that variance works, right? And it's interesting because then you can also handle each environment separately, right? So I can say env.run 42a, and this is going to get rid of the pending integer in the computation, right? So here we have only now the string environment pending, and then we can add.run path b, and I'm gonna ask again, Julian, can you guess the result of the C here, the type?
So this should be like the int string pending any, right?
Exactly. There is no effects pending, right? So because we handled everything.
Yeah, sounds good. Makes sense. Right. And if I remember correctly from the documentation, you also have a nicer syntax to apply to run some effects. Like you have this pipe method, or something like this.
Oh yeah. We don't. I think we don't use much the pipe methods. I've been trying to use more, but you can. Pipe is basically, it's the same, similar to Scala's pipe methods. That is, you're passing the left-hand side to the right-hand side functions. So you could also do it like this. It's very convenient for effect handling because you don't need to do all the nesting and etc.
Or you can do multiple pipes, right? You could say pipe env run 42. Somehow I kind of like this, one line, one pipe. I don't like, it's kind of like, mapping one after another. It's just, I guess this is a question of style, but it's nice.
And you can even do like regular transformations. So you can do a map +1 here in the middle as well.
Magic.
Makes sense. So, actually you can't. Because I have a tuple at this point. Whatever. But you get it, right?
Yeah.
So that's how you run. And there's not only the environments effect that has variance. We also have the aborts effects that can track multiple failures. So the environments handling one by one is something that I think, for example, Zio doesn't support. You have to, at the end, provides everything. It's a different paradigm in terms of how it wires the environments.
There is provides some, but it is very difficult to use, and I think it's rarely used because of that. I think in Zio, one of the other problems with error handling and with abort, with equivalent to aborts, is there's no way to basically catch one of the values. So because they're using Scala 2 and the way the variance is set up, everything has to be caught, or you can only basically add things to the abort channel or the error channel. And so this is something that I found quite annoying because let's say you have two values, two potential values in your error channel, a string and, an int. You can't take away one of those. You have to, basically take away both of them. And so that makes your error handling has to be all at once, which can feel cumbersome.
I see. So you mean it's a bit like if you had like a partial pattern match when you would say, okay, I want to handle this exception, but not this, this type of errors,
exactly
but
right.
not this other type.
Exactly.
I see. And so maybe we could have a look at this, like, for example, in this example, let's say we want to add some error handling. Let's say I want to fail if the string is like longer than 3 characters, something like this. How would it look like?
So let's simplify here just to make it easier,
make it more concise.
So you can, for example, say, I think we have abort.when, right? Yes, abort when int value greater than 10, for example.
Okay, yeah.
And then you can fail, I don't know, maybe we can fail with a string. Int
is too big.
Too large. Right, so here, let me, can you read this well as well?
Yeah, I can see it.
Okay.
Perfect.
So this is going to be adding the pending aborts to the pending set. So this is not going to be compiling because we have like the new aborts effect that's not tracked.
This will be can you wait a second? Because I think this is cool to see like what are the error message you get, because it's cool to, this is like as a beginner when you just start to use your project, you always do something wrong, and how can you debug it? So it will be useful to see. So what do we see here?
It's essentially a type mismatch. We don't have control over the type mismatch error message. I try to do like with macros implicit. It's really hard to do that. I opened a ticket on the Scala 3 repository to try to have better custom error messages. But here you can see that you're basically saying like we were expecting the environment effects and you are getting an abort effect.
Yeah.
Right.
Yeah. Okay. Makes sense.
And we can add it here, abort string.
But to be honest, I was expecting much worse because, especially when there are like long types like this, quite often, like at least I'm maybe more used to Scala 2 than Scala 3, to be honest. But I remember seeing these massive type errors, and they are undecipherable. You kind of need to copy paste them in your text editors and align it. And so I was a bit expecting this. So it's cool.
Yeah, it's not so bad, the error message, but I must be honest, like if you have a large number of effects, it can be hard to find like which is the effect that's mismatching. So that's something that we hope that eventually to be able to improve, but the language doesn't allow us to provide a better error message in that case. But it's reasonable right now. Cool, so here we are with the abort string, and then I can handle the aborts, right? So I need to know.
So how do you handle errors? So what does run does?
So the abort.run is, I'm going to go back without the pipe.
Yeah, of course.
Or maybe let's just keep these two pipes.
Yeah.
So this is going to be handling the two environments. So we are going to have only the aborts effect pending here, right?
Yeah, makes sense.
Whereas the compiler is not.
I think Metals sometimes has trouble. It's like I can see the type annotation. I'm not sure why it has trouble inputting it.
Yeah, it's here. Like if you hover, it's not loading. Oh, there it is.
Yeah.
But then if I go here, I don't know, Metals, and string and abort string, right? Let's actually add two aborts. I'm going to abort just to, I don't know, maybe just 42. If the int value is lesser than 10, I'm aborting with 42. And here, the abort affects variants as well. So, and it's similar to 0. You can use the R, right? So the failure can be a string or an integer.
I see. And here, if you were, because I think like in practice, you will most likely use another string. So here, if instead of 42, you would put another string, it wouldn't change the error type, right?
That's correct.
Yeah, makes sense.
So here, let me add the int here. So here we are handling the environment's effects, and then we get only the pending aborts, right? So, and this is what Adam was saying, that we can actually just handle a single effect from the pending one. So I can say I'm going to run only the aborts for int values from C.
Okay. And what is the result type of this?
It's going to be the aborts without the integer pending. I don't know why is okay.
I understand the effect.
You're forgetting the result. Don't forget the result type, Flavio.
Oh, yeah, that's true.
So internally we have what we call result, and the idea is it's very similar to an either, but it enables a few things differently. One, it has allocation-free successes. So in many cases, you can completely avoid allocations. And then number two, it enables a second error channel called panics. So there are some places in your application where you do want to just sort of fail bluntly. And so that's why we have this other type called result. If you've used Zio's exit, it's very similar to that, though it doesn't allocate.
So a result is like something that has three cases, right? So it's like a success, a failure, that is you can customize the error type, and the panic. What will be the type of the panic? Is it a throwable?
Yes, a throwable.
Yeah, so any throwable, basically.
Okay, that makes sense.
It's essentially a mix of try and either, basically. So if you see
I understand
what they provide. So here I'm first just handling the int abort. And then I get a result that may be a failure integer or the result, the actual result. Make sense? So here we can handle just one specific effect, a specific failure. And then we can, let's say, abort.run string. And that's going to be a bit more complicated because we are going to get to a nested result. Let's see. No, it's not working. Great. So this is going to be a result that may fail with a string, right? And R might have an actual result for the other failure.
Makes sense.
And this will be pending any, correct?
Oh, yes, that's true. Let me.
So at this point, we've handled all of the special effects, let's say, and the final evaluation is required to get the result type out of this pending any.
Yep.
Makes sense.
So I'm just going to do an eval here. So as we are passing 42, we are going to get the integer failure, right? So I don't think we are using show for the run from Kyo app. Let me do something. So I'm going to just map show. So yeah.
And what does show do? Is it like a println or something like this?
Yes. So Kyo uses opaque types to represent things. So the result type is actually, if you have a success of a value, it's actually just the value. There isn't like a wrapper around it. So if you call just tree_string, you're going to get like the internal representation. If you call show, you're going to get the actual proper representation of the type. So here we can see.
So you mean that if it was a success and you would have gotten just the value, but you wouldn't know what will be the type of this value, right? You wouldn't know that it's a success of this.
Mm-hmm.
That's correct.
You would see an internal representation that doesn't show the structure of the result itself.
Yeah, makes sense.
So, and then if I change this to far, we are going to get a success within and a failure within it. Mm-hmm. Right? So because then as we are handling failures separately, the integer failure is going to be handled initially here. And then that's going to be producing a failure. But then when you handle the string, it's already a success because the failure is already handled.
I understand. Makes sense.
And that's something that, for example, Zio doesn't provide. And I think Cat's Effect also probably doesn't have anything like this that allows you to handle specific failures out of a set of possible failures for the computation.
And so, for example, here, if we wanted to, like within our program to say, okay, I want to handle, in case, I don't know, in case maybe I get a string exception, I want to, ignore it or something like this. How would you do this, for example?
I think a more common case might be like, you get a throttling exception, you don't want to retry it, or if you get a, invalid request, you might want to actually fatal because you're trying to, alert the user, okay, this is something that's important. So, we have a few different methods. I think there's now a run, I guess you could just run one exception type, for example, and it uses similar to a class tag to enable, pattern matching at runtime to work as you would expect.
That's very cool.
Yeah, and to make this work, we actually had to implement like a new tagging mechanism to support union types and etc. So it's something that we had to use to be able to provide this feature. And you were saying like if you want to ignore would be like passing from a typed failure to a panic, for example, right? Because you can't just like ignore a failure. It's going to be there. If the computation is failed,
that's true.
The failure is going to be there, right? So ignoring is the only option is passing it to the untyped failure panic channel.
Yeah, makes sense.
Yeah.
That's really cool.
So maybe we are taking a long time on this part of the presentation, but I wanted to talk about effect widening. That's an important one. This is something that's different from other effect systems. In Kyo, if you have, for example, let's say I have an integer 1. This is actually, let's start from something different. Let's say that I have a computation that has an abort, a pending abort with integer, or let's using have. And then you can do something that's we call type widening. That is, you can take a computation that has fewer constraints, fewer effects to be handled, and pass it to the same to a computation with a signature that has more effects. So you can say there's an integer with int and I don't know memo, for example, right? So essentially, you can pass computations with fewer pending effects to a signature that has more effects. And that's similar to Zio. Like you can pass like a computation that has subsets of failures to one that has more failures, for example. So in that sense, it's similar. Go ahead.
Correct me if I'm wrong, but I guess this is what was happening in your for comprehension, right? Like each line had only one effect, but it would widen to the union of all the effects. Is that correct?
At that point, it's a bit different. The way that it's accumulating effects there, it's just like the actual transformations accumulating them. Here, we are actually just doing like a type level casting, type safe casting of computations. It's a big
But
difference.
isn't the for comprehension requiring all the lines to have the same, how do you say, the same effect, essentially the same, like you can't mix, like, let's say, a list and a stream and an IO because they have different effects?
That's true, but the beautiful part about Kyo, because we have one uniform pending effect, this less than symbol, you're always operating within the same monad. And so this is sort of the magic behind Kyo and the reason why it feels so fluid everywhere you use it. You'll find that when I use a for comprehension, when I use map, flat map, whatever I'm using, it's all going to work together beautifully because it's always the same monad, even though it's using different algebraic, type level tracked effects.
Yeah, and you said that even a pure value, like just an int, can always be raised to a pending value with this pending any. That's correct?
Yes, and the reason that's so useful is often function signatures. You can accept, as a function argument, you could accept something that requires environment variables or requires something more complex. And the beauty is if you decide in one branch of your code, you're going to pass in a pure value, in one branch of your code, you're going to pass in an actual set of effects that works just as well.
I'm just thinking this might be probably niche, but it's something annoys me a lot in Scala. When you have a for comprehension and, let's say you need to start with an arrow, you need to start with something with an effect, and you can't have an equal, so you need to move as a value above. But I guess with Kyo, you don't have this problem because you can use an arrow all the time because you can say, okay, if my thing doesn't do any effect, I can always lift it to the any effect and it should work, right?
Actually not. Earlier versions of Kyo had that characteristic, but if you start a for comprehension with A1, for example, that's not going to be triggering the widening to a Kyo computation. It's possible to provide that. Earlier versions of Kyo was behaving that way, but then the triggering of the widening end up firing at places that you don't expect, right? So this mechanism provides a better behavior. But Adam is doing such an interesting trick because you can explicitly say widen this to a computation, and that should work.
And if you didn't do this, like what would happen?
So I don't think it would compile, right?
Let's try this here. So if we remove the type annotation.
Yeah, if you remove the type annotation. Okay. Too bad.
Which I think is a good thing. This is probably the way things should be.
Yeah.
But yes, sometimes when you're being a little bit sneaky, you may want to add a type annotation to let the compiler do what you want it to do. So
I guess you could always add a method on everything to say like lift a pure value into an eval of an pending and could be useful.
We have Kyo.pure that's basically like lifting.
Exactly.
In most cases, you don't need to lift manually, but there are cases where the compiler has trouble looking for things, and then you have to lift. But it's very rare.
To be honest, this was just like something that just annoys me always with this for comprehension. So I just thought, maybe I can finally get rid of this, but not completely.
Actually, there's a new compiler flag in the latest version of the compiler that enables that. So I think it's the better fors.
Better for comprehension.
Experimental. Yeah, it's experimental, but you should be able to start a for comprehension with an equal sign now. So
this would be great. Awesome.
And just to finalize with an example as well. So as we mentioned, you can also lift directly from pure value, right? So event one, this compiles as well.
Yeah.
Makes
sense.
And that becomes like really powerful because if you have, for example, in other fact systems, if you have a flat map and then you have a branch that is a factful, another branch that's pure, and then you have to lift it, and then people have to use map or flat map, and that's something that people, especially newcomers, have trouble with. So Kyo has this simplified monadic interface where you have this automatic lifting of plain values to computations, and that allows us to basically not need the distinguish between map and flat map, because you can just like use a regular value as the return. So in Kyo, we have both map and flat map, but flat map is mostly for comprehensions. But you can use a map, for example, for everything. So for example, I can do app.get integer. Let's use v1, and then I can get app.use, I don't know, a string, and then I can v2, v1, v2. Makes sense? So in other effect systems, you would actually I shouldn't be using use here. Sorry.
Yeah, because you want using map.
Yeah. Get and then map. Use is basically get and map. Sorry.
Yeah, I understand.
Have omitted that. Map, and this is you were asking about how the types are being inferred by the compiler, but if you were in a for comprehension, this first computation would have only the env effect for integer spanning. Okay. And then once you apply map, the map is going to be bundling the effects that were already in the initial computation, plus the effects in the function that might be performing there. So it keeps accumulating on each map, flat map, it accumulates the pending effects. So it's not really widening of effects, it's a different mechanism of like tracking effects on transformations. And that's
so essentially every time you have a map or a flat map, you say, okay, I take the effect that I have here, I take the effect that I have here, and the result needs both effects. And if it is the same effect on both sides, it doesn't do like IO and IO, it just keeps on.
They get merged. That's it. That's right. Yeah.
Yeah, it makes sense. And this is done by the compiler, right? This A and A is A, right? You don't need to simplify it.
Mm-hmm.
That's really cool.
So something I want to say, so this is essentially all the building blocks you need to learn to use Kyo. So it's just like there's one monad, it tracks effects, you use effects, they are going to be tracked automatically as you compose them, and then you have to handle them using the run methods, right? So the mental model of how you use Kyo is exactly that. And then there are the different effects that have different features, right? So you learn like the specific effects, but you have the same framework for expressing everything that is basically the pending type, effect widening, and transformations, as we saw here. So if you are starting with Kyo, just like start from that and then try to use the effects, learn the effects to like form a good mental model of how to use it instead of trying to reason it about it in terms of other solutions, right?
No, I think it's really cool. I think it seems very ergonomic from the example you showed me. But from what I can see, there is essentially two syntaxes there might be more like to combine Kyo's program. You can either use map or you can use a for comprehension. Do you have any preferred method? Any method that you recommend to your users? Or?
So we actually have different dialects in Kyo. So I would say the pending type, the monadic interface is the main one. It's the most mature one. It's the one that we spend a lot of time like designing and etc. But we have an approach where we want to envision a migration path where people can start from something simpler to something more complicated to something more advanced, right? So we have direct syntax support. That is basically a macro that transforms to the monadic computation to the pending type. And it's based on WCP as async. And the idea is that people like newcomers that are coming to the library, to the language, can start from direct syntax that's simpler, more similar to other solutions in the market. And then you can use the monadic interface that has already some important simplifications, like the difference between map and flat map not being necessary anymore. And once you are more proficient with like using the monadic interface, we have a combinators module that is basically a similar encoding to Zio, where you have more richer combinators that do transformations, but it's a bit more advanced pattern of usage, basically. But we are envisioning like being able to attend like people that are very advanced functional programming developers to people that are just starting like coding for the first time with the functional programming.
No, I understand. Makes sense.
Yeah, I think even the map and flat map merging is such a big simplification. I've been working on a project for maybe about 6 months now with a friend, and he had basically zero experience with Zio, zero experience with Kyo, and I think he's become quite proficient with Kyo in a matter of a few months, and he's contributed at a high level to that project. So I think it becomes very simple to explain to people when you just have math.
Yeah. But I think, like, to me, I mean, I'm not a beginner in Scala, but one thing that I found amazing with this presentation is how, I mean, the graal of, the effect system is to be able to have a nice ergonomy, like to be able to combine different effects together. And this seems to be doing very well. And also like to be precise, because quite often, like, Zio kind of like make this choice, say, okay, what are the most common effects, let's bring them all together, and okay, this is going to be, we have an amazing interface, but we're kind of limited to these effects. And I think what's really cool with your implementation is that you can have any number of effects, they all can combine together, they're not connected to each other, but at the same time, the ergonomy, like the way you can combine them, is like it's not, there is no boilerplate, so this is really cool.
There are some limitations. So actually, you only two major limitations in terms of handling effects and composing. One is I/O shouldn't be handled by the user, right? So we have like Kyo app that should be handling the I/O effect, so you don't break preferential transparency, basically. And the other limitation is when you are forking computations, there are some effects that can be forked, some effects that cannot be forked, because basically the semantics of effects, like, let's say we have like a var effects and you fork multiple computations that is like, this is shared states. How do you handle these shared states, right? So Kyo limits, in that case, how you can fork computation. So these are like the 2 points of like that are restrictions in terms of how you can compose effects. But in general, you can mix and match like all different kinds of effects. For example, we have software transactional memory with parsing, using asynchronous computations, can mix everything together, basically.
But one thing is that, I always heard that, the big problem with monad is that they don't compose. So you cannot say, okay, I can take this monad and I flat map it with another monad and they work. So what I find interesting with your implementation is that you essentially say, we can compose any effects together. There is no limitation. They are all in a bag. And in a sense, like, like when I remember when I learned about monad transformers, it was saying it has to be defined, the effects have to be defined in a specific orders because they don't commute. You say, if I have, let's say, an option of a function, like an option of an environment is not the same as an environment of an option. And I'm curious, how do you step aside of these problems? Like,
yeah, so the way Kyo works is that effect handling is what defines the behavior of how things are going to be executed. So there are some effects that are order sensitive, mostly the ones that are doing short circuiting, like for example, aborts. You also have the choice effect that is for backtracking that also does short circuiting. In those cases, basically the order that you handle things is going to be presenting the behavior that you want to have. And that's reflected actually on the types, right? So for example, if you are handling the aborts effect, you're going to get a result as a type of the computation that's going to be produced. Makes sense? So once you handle something, if it's order sensitive, you're going to have a type change in the value the computation is going to be producing. So it's very easy to see how the execution order is going to be happening because it's perfected on the type at the type level of the computation.
I guess one thing that I'm a bit confused, and I probably need to spend a bit more time to think about it, but it's like, I tend to think of, I define my program, let's say I have first an environment variable, and then I do something based on this environment variable and it can fail. So I have an env and I have an abort effect. But you're saying that, we at the end, you can decide in which order you handle these effects. You can first handle the env or you can first abort the abort. Is that correct?
Yeah, that's
so one thing that I find curious is that you can potentially handle the abort first, even though you can't run the things that aborts before you pass the env, like, because the things that can fail depend on the abort. So this is what I'm a bit confused, like, around.
This is the core part of the effect system, and I think this was what confused me the most, and actually what intrigued me to contribute. I was so confused. How is it possible that I could handle a failure before I even know the failure might exist? And I think the beauty is that you are still suspending the evaluation. So as long as there's pending effects in the type signature, even including any, then you still have to, evaluate those, and you still have to wait for the final transformations to be made. And so when you think about abort.run, it's not just handling the error in the case of try catch, it's actually transforming the result of the monad. And so in a very subtle way, you're supplying function transformations as you handle effects, and the type signature simply ensures the type safety of the operations.
Yeah, I see, because you don't get the value yet, it's still an effect. So essentially what you're saying, when you handle just the abort, you're saying that, okay, whenever there will be something that is aborted, this is what you will need to do with it. But you don't yet do it because you haven't got the environment variable. Is that correct?
So it's actually, it's hard to explain like the kernel, like it's actually simple. Like there is, it isn't much code and it's well documented. So if you want to take a look, but it's a more advanced code. But what happens is once you have the handlers handling, they keep installed until they reach their execution point. So if you have, for example, env suspension that's going to be failing later, and you handle abort before env, what's going to happen? The computation is going to suspend at the env effect first. It's going to go back, finds the env handler, get the value, and then continue executing. And then eventually it's going to fail, and it's going to be caught by the abort handling later. Maybe
I think I get it, but
but the core is very simple. When you are handling effects, what you get is basically the value that was suspended with, like the failure, for example, and then a continuation that is from the points of suspension up to the effect handling itself. So you get like the full continuation at that point. So the building blocks are very simple, but I understand that's something more complicated to follow because it's a different way of encoding computations.
Yeah.
But it's also the way that we have other libraries or other languages doing, right? So it's basically the algebraic effect solution.
No, it's a really cool idea, and so makes sense. And in terms of, one thing I'm curious about, one thing I like about Scala, Java, I mean, let's say in general, object-oriented is, like the dot operators, the fact that you can say, okay, I have some kind of value. What can I do with this value? I just put dot, I ask my ID, what can I do with it? So this is one thing I was wondering with Kyo, and I think also Zio, I think, is really good in this area, is that they provide tons of methods to do with your Zio, essentially. And I was wondering how you discover things you can do in Kyo. Like how do you say, okay, what are the different effects, and what can I do with these different effects?
Yeah, I can take this one. So I think there's really two methods, and what you're describing is definitely the second method, which is the Kyo combinators. We've tried to provide as many combinators as you can imagine. You can type dot, and then whatever you can think of, and your IDE will suggest all of those. Okay. So the fish operator, the asterisk and then the right arrow, that's very common in Zio. So that's something that we provide. But also things like providing layers, things like running aborts, things like panicking instead of, handling an exception. That's all possible in the combinators. But I think Kyo Core takes an intentional approach to expose only operators on the actual effects. So I would say not only, but there are primarily, if you're looking at async, the async operators are within the async object. And so this can feel a little confusing to maybe more advanced users who are very used to the dot notation, but this is a very common pattern in other languages and sort of other libraries. So I think the principle here is that it separates the concerns of each of the modules very well. And I think the combinators sort of satiate the idea of, I need all the dot syntax right, tip of my fingers,
Yeah, so I understand. But I guess also one thing that's probably good for you is the fact that there are only a handful of effects that you need in most cases. Zio is a good example of this. You need the environment, you need the error, and you need the IO, and this gives you 99% of use cases, I guess.
Yeah, that's correct. One distinction for Kyo, which may be surprising, is async and IO are different. So in Zio, they sort of implicitly stuck this in there, and I didn't realize it for a long time, but your Zio is actually async, which can require environment and abort. Whereas in Kyo, if you want to use I/O, it's for just direct suspension. Whereas async is suspension, including fibers, basically.
Okay, I see. Also, so how do you define like an effect essentially? Because like, let's say, I'm a user, like what let's say, would you say, okay, this deserves to be a new effect, or this is just like an IO, or like, how do you categorize this? Like,
We still don't recommend users creating effects. So we have an approach where we are exploring all the solutions and for the library and how to structure it. So, but the kernel is already very safe right now, but we have a limitation around variants and tags that we need to fix before making the 1.0 release. So that's the main reason we are not recommending users to create new effects. And I think having creation of effects as something that's be like a main user-facing feature, I don't think it's a good approach. Like if you see like Haskell algebraic effect libraries and other, like you normally like have the user, the first thing they see is like how to define effects, and that's a really high level of abstraction, right? So right now, the way Kyo is structured, you don't need to define new effects. You have like all the basic building blocks like you have in Cats effects or ZO, for example. And then creating new effects would be like an advanced feature that we are going to be making user-facing at some point, probably for 1.0 for sure. But it's actually very simple. Like if you see how other effect systems, other algebraic effect solutions are encoded, it's quite involved. Like you have lots of magic and tricks, and in Kyo it's like very simple. Like you just suspend and you get like the inputs of the suspension plus the continuation, and you can do whatever you want, right? So it's really, really powerful in that way.
If I remember correctly, there was also some question I had around the effects in the documentation is that, you have IO is an effect, so you can have int pending IO. But let's say you were mentioning also like console or like clock as, I don't know if you mentioned it as an effect, but they are kind of in the same part of the documentation. But like when you say like clock.now, it doesn't give you like, let's say, an instant pending a clock. It gives you instant or time pending IO. So does it mean that clock is not an effect, or it's kind of just some function essentially? Or
So the choice of tracking effects or not is actually something that's orthogonal to how Kyo is structured our algebraic effects. I believe ZO in previous versions used to track like the environment clock or the environment console, right? And they decided to not track that anymore. And in Kyo it was the same thing. Like I used to track console, and eventually I decided, okay, let's not track that because it's not very valuable to track those. Like if you are in a computation, you just add some console.println to debug something, and then you change all the signatures. You have to add the pending console. It's not ergonomic in that way. But it's still an effect. Kyo, the kernel, when you have the pending any, there is an internal effect that is for stack safety, but also for contextual values. So you can have a locals that are going to be provided with computation, and the clock is basically a local value that is not a separate effect. It's based on another effect, basically on the local effect. So you don't see the pending console, but you can still inject, for example, a test clock, or we have like the time shift method, so you can accelerate things or not. So it has all the behaviors that you can do, like using injection with proper tracking, but it's like internal, so it will provide better usability, basically.
Yeah, I understand. Yeah, makes sense. Like, I mean, I guess this is really the more ergonomic than theories. Like, potentially console could be an effect, but it's just like will be some boilerplate in the user code and doesn't bring any value. So that's why it's returned an IO and not a console effect. Is that correct?
Yeah,
a good question to ask yourself is, what does this effect do that transforms the results? In the case of things that side effect, like a clock or a console, the result is already highlighted by the IO, and that's basically the best that we can do. There maybe is a potential if you had a console that was, tracking all the outputs or something like that. then it might make sense because the running of the console effect could provide all the outputs. But in our experience, it has not been very useful. So I think if there's some use case you find where you need an effect to track something, then feel free to open a issue or a PR, and we're happy to look at it.
Yeah, I guess as long as you are able to inject a test clock or test, console, I think this is the main thing that people may want with a console or a clock, to be able to simulate it. But as long as you're able to do this, that's perfect.
That's true.
Cool, sounds good. Okay, so maybe let's take a step back to talk about Scala in general and Kyo. So I believe that you originally Kyo started in Scala 2, but now it's mostly in Scala 3. Is that correct, Flavio? Or?
More or less, the initial versions of Kyo was only Scala 3, and then eventually Scala 2 was added. And for a while, it was both Scala 2 and Scala 3, but it became like a big burden to be providing. So imagine like all these like advanced features, like type level transformations, like the signatures, type intersections, unions, like it was like all hacking Scala 2, and then like the proper solution in Scala 3, and then we couldn't use the advanced features in Scala 3 because we have to support both. It was very limiting. At the time, I was very worried about like having only Scala 3 because it's like a new language, adoption, etc. But at some points, like I couldn't do, for example, the result type without allocation with good ergonomics in Scala 2, for example. Or like we also have the maybe type that is like an option without boxing as well. And those things were like really difficult to do in Scala 2. And in Scala 3, actually, the first versions had some limitations that made it hard as well. But eventually, Scala 3 became much better, like new features, things got like fixed and etc. So I decided to just drop Scala 2 support. I wasn't sure about the decision at the time, but like looking back now, it was the best decision for the project. Like probably we wouldn't be where we are today in terms of features and functionality, not even close, if we had still Scala 2 support. And Scala 3 has just like features that are really, really amazing, especially if you are trying to emit like more optimized bytecode that is a little more friendly to the just-time compiler, like you avoid allocations. You have like the bright building blocks in Scala 3 that are just like much better than Scala 2. And correctness as well, like the Scala 2 type system like could like sometimes become like more not very good, like, or have some edge cases that were strange. In Scala 3, like things really work well, like the basis of the language, the fundamentals feel much more solid in Scala 3.
Yeah, I see. And so could you highlight a bit like what are the, you mentioned like about performance, and I think like many people are interested about this. So what do you think makes Scala 3 potentially more performant than Scala 2? Or how can you, it seems that you're saying that you can potentially write Scala 3 code that is more efficient. And why is that? Like what are the main features for this?
So I would say opaque types and union types are the main ones. There are still some usability issues. I think over time the compiler is going to be evolving the language, but you basically can represent abstractions without boxing, right? So, for example, you can have like a maybe that is internally just like maybe of A that is like option of A that is internally just an A or an absent. So there isn't like a boxing or even the result type as well. The other main feature is inlining. It's a feature that's a bit difficult to use because like if you inline too much, you can end up with worse performance. So you have to be conscious of what we are inlining. And we basically use inlining in Kyo for two main things. One is staging computation. So when you are composing computations, the way that the code is generated, it allows the just-in-time compiler to see the execution across multiple transformations and optimize that across transformations. And that's like a major optimization in terms of performance. And the other way that we use inlining is basically to avoid function in patch overhead. So if you have, I don't know, like some collection dots for each passing a function, right? We use inlining, conscious of like inlining as little as possible. So we don't need to allocate the function to be dispatched, for example. And that like plays really well with the just-time compiler because then you get like different codes, and it gets optimized like much better in terms of execution on the JVM at least.
And how do you benchmark all these optimizations? Like, how do you do this?
We normally use JMH, so we have our Kyo bench module, and we just like write micro benchmarks, profiling sessions, and inspect it. I have a background on performance engineering, just time compilation, so it helps. But it's essentially these techniques like using opaque types to avoid boxing allocations and inlining to avoid function dispatch overhead.
Because I also see that you have your own, not full collection library, but you have some, essentially some collections that you use within Kyo and that you also potentially let users, like it's some kind of sec or some kind of like where you can append or someone you get with an index. So are these also meant to be used like independently or?
You can use, there's a module called Kyo Data. And this is actually something that I started using. I initially was not using in my project, and I started integrating into my project that I built on Kyo, the effect system. But you could actually use Kyo's, data module by itself without any interaction with Kyo core, any of the effect systems, effect handling. So if you want a very ergonomic set of, option equivalent, your either equivalent, as well as especially the chunk. I think chunk is maybe 80% complete right now, as in it has all the methods, but I think there's some further optimizations required. But in a lot of basic cases of building a collection with appending or these sorts of operations are very optimized compared to the standard library. So I found them quite useful to use in my application.
And do you have any benchmark for the, when you have a collection that is like similar to the standard library to compare like the performance of yours versus the standard library?
Yeah, we do. I think this is probably the least optimized aspect right now. We've mostly been focused on ergonomics of the chunk because like chunk and all these, maybe and all these, because that's most important. And then the beautiful part is once you adopt it, we can start to add more and more optimization over time.
Yeah, because I was thinking that, it's always tricky for if you have a new application, you can start from scratch and choose whatever you want. But when you have an existing thing working, it may be tricky to start using Kyo. And this might be like, for people who have like performance sensitive applications, could be potentially a good way to try Kyo. To say, okay, maybe I can try the index sec from Kyo and this kind of like something simple to get.
Iterative approach. Yeah. There's also an integration with Zio as well as Cat's Effect. So one of the things I have not explored yet, but I've used it maybe minorly with Zio. But one of the things you could do if you have a larger application is migrate a small file or some section to Kyo, and then directly use the interop functionality to enable running your Kyo effects within the Zio application.
Mm-hmm. And if I'm correct, also you have your own runtime, or Kyo runtime, correct? And this is the runtime, you can use it potentially with Cat's Effect and with Zio application.
That's correct. Yeah, Flavio can talk to the details of the scheduler itself, but the actual integration is very easy to use. You can just, you have a Kyo app default, I think it's called, or something similar to that, and it just integrates the Zio runtime, the Kyo runtime right into your Zio application. So in my very basic testing, I noticed some pretty good performance, but there's definitely a lot more, we definitely are interested in getting people's applications up and running on this.
So what are the benefits of the Kyo runtime versus like Cat's Effect or Zio runtime, Flavio?
Yeah, so the runtime, when we say runtime, it's essentially the scheduler, right? So Kyo scheduler, so as I said, like we have different modules, like we have Kyo Data that's fully isolated, no dependency on the effect system. And we have the scheduler module that is also fully independent, and it's cross-compiled to Scala 2. It's all the only modules that we cross-compile to Scala 2. And it's also Scala native. So if you need a scheduler for Scala native, Kyo's is working already. And the scheduler it comes from a lineage of schedulers I've been working on for the past year. So at Twitter, I worked on a Fiber scheduler implementation. So basically introducing work stealing, fibers to finagle at the time. And then I worked at Nubank with a similar solution, but focused on closure. So basically like the scheduler with all the features. And the main thing in the scheduler is the adaptive mechanism. So the way normally large scale applications or even like lower scale applications execute is normally using containers, right? So you have like the CPU coda, and then you have CPU throttling. And what happens there, if you have too many threads executing in parallel, you can consume all the coda very quickly, and then you get throttled. And throttling is basically like the container, the JVM, everything, the Linux layer, they don't get any CPU share, any CPU execution during throttling. And it's like a car, like you are driving the car dies, and then you start the car again. Then so that can introduce a lot of overheads, a lot of degradation in systems. And the way that Kyo fixes that is by having an adaptive policy for the number of threads. So the scheduler is always monitoring the execution of threads, and it's not based on simple like thread compensation policies or anything like that. It's actually measuring how reliably threads are being executed. And as you introduce degradation, for example, because there's a CPU throttling event, or because there's a GC pause, or because there's some network issue, the adaptive mechanism is going to detect that and then reduce the capacity of the system, the parallelism that is allowed for the system to use, so it can recover from that event, right? So if the system is under pressure, you can get like better peak performance that way, because you are basically avoiding like the limits where you get to a bottleneck like GC or maybe CPU throttling, for example. So that's like the main innovation. It's also work stealing scheduler, so to distribute workloads across workers. But it's a different way of doing work stealing that's more lightweight as well. So it's a very much more optimized than you've seen other similar solutions. And there's also an admission control mechanism where you can plug your incoming workload saying like, should I accept new work or not, right? And the scheduler can tell you that. And it's based on like all the measuring of the thread scheduling, degradation or not, like the queuing of the scheduler. So you get like a really good picture of when you need to actually reject workloads and do back pressure of the workloads. And it's a fully isolated, like I said, Scala 2 cross-compilation, and there's 2 integration. Actually 3 now, right? So we have Paco integration, Zio, and CatEffect integration. So it's a good way. If you want to adopt Kyo, I would say maybe try the scheduler first, trying like in environments, or just like a small rollouts of the scheduler if you have like a larger deployments, right? Or maybe adopting Kyo Data, that is like a fully isolated, like alternative to option to tries and etc. with better performance. So, or even like using Kyo itself, like Adam said, like the integrations with Zio and CatEffect, like migrating parts of the system to Kyo, for example. So yeah.
Flavio, what about Netty? Do we have a admission control for Netty?
What do you mean?
I think we have admission control for finagle, right?
Yes, I think so. I had really good success at Nubank, like with admission control solutions, basically to ensure systems continue working, right? So you can, if you are in a large scale deployments, like there can be like situations where things can be like, the system can be under pressure and can have a lot of degradation. So having the adaptive mechanism to avoid reaching bottlenecks and a mechanism to reject workload, to push back on the overloading, it's really effective for systems to continue working even when you have like a major outage or a major degradation event, right?
And in most effect systems, the input to the workload, like your server, your HTTP server, can be actually completely disassociated from your runtime, your effect system runtime. So this can create overload because you might have infinite incoming requests, whereas your effect system can only keep up with so much.
And so what would be the things that people like, let's say, just because I'm very not very good with performance optimization, but so I'm just thinking that in which cases would you recommend people to try out the Kyo runtime, like Kyo scheduler, like when let's say what would be the problem they are facing with their current scheduler, and this will say, okay, when I'm facing these kind of issues, I should give it a shot to Kyo.
I would say if you need better scalability and better peak performance. So, for example, if you have a large-scale deployment, if you are able to reduce the cluster by, I don't know, 2%, it might be a few $1 million, for example, depending on the deployments, right? So if you have like something that the cost of the system is becoming too large, or you have instability, or you have higher latency as well, I would say like trying out but in general, it's a full replacement for any workload in terms of scheduling. So you could like take your CASFX or Zio application and migrate to it. There are a few knobs that you can configure. It's all documented in the code. But we hope, at least at Nubank, we were able to get to a set of tuning that got like working for several kinds of workloads. And Kyo is new, right? So the scheduler, and we need like adoption feedback to be able to find these sets of parameters or any problems. But it's very, I would say it's probably the most mature parts of Kyo. Like the scheduler doesn't change much because like it's stable for a long time now.
Yeah, because I think, sometimes it's a bit of an egg and chicken problem. Like, people don't want to give it a shot because no one have tried it in production, but, if no one put it in production, no one will give it a shot. So you're saying that, at Nubank, you used it in production with success, and
it's a different solution. This one is a new implementation from scratch. So there isn't so the structure, the way things happen, like all the implementation is all different, even like the monitoring of degradation, etc. But it's coming from experience, right? So I've been hired to do this work more than once, right? So I don't know, like if companies would hire me now to do that, so it wouldn't be maybe any company like to be able to
you're saying like
that,
people pay you to do this, and in a sense you can get it for free.
Yeah, exactly. Maybe you can do just some back and forth, like trying like and seeing the results and like asking questions that we.
And I think, probably in most companies, you always have either a new project or you have like an existing one that may not be so sensitive. So you can give it a shot in this low-key application and see how it goes. I think it's an easy way to give it a shot to Kyo.
Definitely.
And, one thing I found is that, performance don't matter in many cases. I mean, in like 99%, not 90%, but in many things you do, anyway, you may not have enough requests for it to matter. But I do think that people care about it because it's something that you can measure. If you say, okay, my solution is 2% faster, you may not care about it, but it's something that it's nice to advertise. So
I think money speaks volumes when in terms of performance. I think whenever you cut costs because of performance, your employer will be happy. So
of course, and and I think this is one thing when Scala needs better publicity is that when you can say, okay, with like real things that have been measured, say, okay, I switched from this solution to this solution and I gained that. This, I think we need more, like, because quite often, like in Scala and functional programming, the benefit we get are difficult to express. You say better compositionability, but it's like, what does it mean? How do you measure? Is it 10% more compositional? Like, it's difficult, but like performance, this is something you can say, okay, I save money, I save time in a measurable way. And I think it's really cool when you can achieve it and following like functional programming principles.
Exactly.
Cool. So if by any chance you have any cool benchmark you would like to promote or share, I will be happy to. I mean, I know benchmark are always tricky. Like you always need to be careful, and but I think it's worth it.
Yeah. So if you look at Kyo's repository, there's a module, Kyo Bench. I think it's the most complete suite of comparison between effect systems available. So there's like a wide range of benchmarks showing the performance characteristics of Kyo, Zio, and Cats effect. So, but we are not publishing the results. So people can get really upset with benchmark results.
I think it's all about the way you communicate. I think you can say it in I would say in the bad way. We say, oh, my thing is 10% faster than yours. Your shit. Or you can say, okay, here's what I've done. I do think that you can have an improvement. And the good thing is with competition, is the fact that the other system can also improve taking your ideas and you take their ideas. And I think this is a good thing. Like, I mean, I guess you were inspired by Zio in some aspect. They can be inspired by some others, and I think this is how we all progress.
Yeah, Zio is definitely improving very quickly. There's a few contributors in Zio working on performance, and it's been nice to see them sort of catch up, so to speak, in the performance area. And I've been slowly, trying my hand at some Zio optimization, basically because of my experience in Kyo, which, is only possible from the learnings bidirectionally, so to speak. So definitely a mutual, positive relationship.
Yeah, we see the benchmark suite as a tool that the community can use to optimize systems, right? So if you're building an effect system, a new one, or if you want to optimize your current effect system, Kyo's benchmark suite can be a really good source to identify bottlenecks, problems, things that can be optimized. So our goal is to do that. And we had some collaborations with Zio in benchmarks and optimizations as well. So we really like to interact with other communities and be able to build something together, or like exchange ideas, exchange techniques, and etc.
Also, one thing I'm thinking is that, when you want an effect system, you don't necessarily choose it on its own for its own characteristic. You also choose it for the ecosystem of libraries around it. Let's say, if you have, like I say, HTTP4S who mostly works with Cat's effect, and you may have Zio who have their own HTTP framework. So I just wonder, I mean, I know that Kyo is very young, so I don't expect to have your old frameworks for everything, but how do you, let's say, if someone wants to give it a shot to Kyo and wants to start a new application in Kyo, how would you recommend them to choose an HTTP server, to choose a config library, how will they work together?
So as I think I mentioned at the beginning, we are using a monorepo approach. So the idea is that think of something like Spring, for example, as a framework that provides you with, like, if you want to do something, here's how you do it. So that's the goal in Kyo. And having a single repository with the same patterns, the same style, the same expectations around all these modules, I think it's going to be a better experience that we have today. Like, for example, in other effect systems, sometimes some libraries are well maintained, some are not, some are deprecated, some use a different approach, or some are like with different patterns, and that's a problem to provide a good experience to the users. So our goal is really provide like a full experience to the user that is cohesive, like with all the same patterns within the same repository, the same code base, basically. And we already have a lot. So if you see the features we have HTTP server, HTTP clients. Oh, yeah. We have STTP integration is for the HTTP clients. We have a software transactional memory implementation, for example. I think the type
of database.
For our database, we don't have anything yet. We've been evaluating solutions. I'm not sure. My initial bias was Quill, but there's interesting Magnum, different approaches. So we should integrate at some point with one of the libraries or have our own integration as well.
And I guess, it's a lot of work what you're planning to do, but it's potentially very good for the user. I mean, one thing I found annoying is, when you have in school to have all this modularity and all this pick and choose, but then you have to handle all the different versions together, which version works for that. I mean, it's a nightmare to maintain. In a sense, if you have everything in a monorepo, you say, okay, here's my version. I know that they all work together. They've been tested together, and that's great.
And actually, most importantly, all of the examples on the README are updated together. So when you publish a new version of Zio, for example, all the libraries have to go adopt a new version, which is okay, given the binary compatibility and all that. But it definitely puts a strain on both the reader of the documentation as well as the the contributors who are basically having to maintain all this stuff.
So it seems that you guys have lots of work on your plate. So next thing I was going to ask you is what about the contributors? So are you looking for new people to contribute to Kyo? And if yes, how does it work? Where do you people communicate, the Kyo developers?
Yeah, I think we're always open for new contributors. I think you can just open a PR if you're interested. The license is in the repo. We have a Discord, so if you have questions about how to contribute or what you want to do. There's a lot of issues actually tagged with good first issue. They're not that difficult, or even if they are difficult, then feel free to ask for help. I would say, yeah. If there's anything you want to add, Flavio?
Yeah, we also have a few bounties. So last year I decided, that's from my personal donation to the project, I set a budget for bounties, and we still have open bounties if people want to also earn some money and contribute with something with the project. And I would say, to me, it's much more about attracting contributors than users, because the idea is that Kyo can live and grow as an independent open source project for forever, essentially. So I don't have plans to build a business or anything. I want to make sure, and Kyo is basically, to me, more of a hobby project. So in my free time, I work on it. But my goal is to continue developing and growing and making a cohesive experience for users with the library as a framework, as a complete solution for all the different kinds of things you have to do as well.
Yes, makes sense. I mean, so it's a very, very cool project, definitely. And I will also add a few links below this video. Like if you guys want to, I guess, a Discord, you can probably join it from this, or so just to make it convenient. And so what is you mentioned at some point that Kyo hasn't reached the 1.0 version yet. So what is the timeline generally, or the milestones that you have in mind for Kyo?
So as I mentioned, we have two main issues that we are trying to address. That we think it's like this. It's essentially like the building blocks. We have to make sure that the building blocks are the ones that we can like continue living with like throughout a long time once we release 1.0. But we are kind of close. It's not too far. So maybe like within the next month, we were discussing maybe doing the first RC for LambdaConf. And we are hoping to do like an RC cycle that's more reasonable, because we had some cases in the Scala community where the RCs were like basically every version is a new library. So it doesn't help much being an RC. Once we get to the RC, it's basically us indicating that we got to a point where we are comfortable with the abstractions, the infrastructure, the building blocks, and we are going to try to keep compatibility as much as possible as well. So people can start adopting the library, because until now, like we've been doing lots of major changes, so it's hard to adopt. So once we get to RC, the goal is to allow adoption, basically.
Yeah, it's a tricky moment, because you always want to put new things in, but at some point you need to slow down and make sure that everything like is stable and ready to use. Which also, like, it's difficult for a maintainer. Like at some point, then you need to say like, okay, this is like the API. I can't break it every day of the week like as I used to do, and
which is definitely, I think, actually one of the reasons that other effect systems maybe have fallen behind, so to speak, is they've had trouble because of the guarantees they've set for themselves. So, I think that's totally reasonable, and you can't sort of just pull the design out from under all these enterprises that have adopted it. So that's why once in a while it's useful to have a new player like Kyo come in and show what the new features of Scala 3 are capable of.
Yeah, that's true. I think, maybe Scala has a bad reputation for like binary compatibility or like stable interface. But I do think it's a bit unfair for library authors and even for Scala, because it was true like 10 years ago. But I do think that, Cat's effect, this is what I know most, but I think people, and Zio, I think to some extent, people have put lots of effort to have a stable API, to have a binary compatible API. And I think it has been very stable for many years. So yeah, I mean, there is a pros and cons to this, but I mean, it's really cool. I think that the Scala community is very mature in this area right now, at least in my
100%.
opinion.
Yeah, I think that's the necessary for enterprise adoption in general, is you have to have stability. So you can't be changing things all the time, or your manager, your director, your whatever of engineering is going to ask you, why do we have to rewrite everything always? So.
Mm-hmm. So what do you think will be the timeline for Kyo 1.0? If you have to guess, like I'm not going to hold you accountable for this, but when do you think it will happen?
I think we're aiming for this year. I think April, we're hoping to have a very stable version of Kyo ready, and people should feel free to try it, adopt it, that sort of thing. And then one of the discussions we had offline was if we introduce anything major change-wise, we plan to include Scala fixed rules once we have the RCs. So it should be very stable to be able to migrate over without any effort.
Sounds very cool. I'm very looking forward to this. Awesome, guys. So I was really happy to have you on the podcast today. I found really Kyo like one of the most amazing projects that is coming now in Scala. And thank you guys for your work. It's really amazing. And really good luck for the 1.0. I know that it's a lot of work in front of you.
Definitely.
Cool. Thank you for having us as well. It was great to chat with you. And hopefully we can do another of this at some point, or even when 1.0 is out.
Exactly. We can do a post 1.0 interview.
That'd be awesome.
Awesome, guys. Have a nice day. See you.
See you.